Welcome, Ji. Today, I am going to discuss on reactive system. Uh, Reactive systems, okay, and what is the reactive system? What are the key properties, and how to implement those reactive systems? For implementing reactive systems, there is reactive stream specification. What specification say, what the API they expose, and after that I'm going to show which are the number of implementation available of those API, and in last I'm going to I'm going to discuss about the Spring, the way they are implemented, the reactive stream specification. Okay, so first, what are the reactive system? As per the reactive manifesto, reactive systems are, they have a four major properties. You can say feature, a capability. First, reactive system should be responsive. Responsive, that means your systems, that's this your system. If requests come within the defined time frame, they produce a response as per the expected SLA. What are the timely manner they should system should respond. That is the responsiveness. Second feature is the resilience. That means in case of any fault or failure happen in the system, still system is able to respond as designed the behavior in the case of failure. The system should be responsive in the case of failure as well as. Third feature was the elastic. Elast was the elastic. That means if your system are able to, if as a client increase the load, now is your system is capable to respond in varying, increasing the number of load. Your system should be designed such way that if the customer are increasing the load, increasing the number of requests, your system should be responsive. And fourth property of the reactive system is the message driven. That means your systems are communicate with asynchronous. Asynchronous communication happen between the components, and all those system components should be loosely coupled and isolation with location transparency as well as. Means if your system your become part became a 1 2 3 system, become a part of one reactive system, and all the communication between your systems are should be asynchronous. So these are basic four, you can say, uh, property of any reactive system. Reactive system should be responsive, should be resilient, should be elastic, and should be message driven. So these are the come from direct reactive manifesto. As per the reactive manifesto, the reactive system should follow these properties. So here we are discussing to implement such reactive systems. They come up with some specification. That specification known as a reactive stream specification. Specification. The reactive stream. What is the reactive stream specification? A specification just you can say standard way. So a reactive stream specification uh, provide a standard way for asynchronous stream processing with non-blocking and back pressure. These are the key features: asynchronous for stream processing, non-blocking, and back pressure. These are the features we are discussing in details. So, reactive stream specifications provide a standard way for asynchronous stream processing with a non-blocking and back with a back pressure. And whenever this reactive strings specification starts a initiative in late 2013 between the different companies engineer like Netflix, Pivotal, known as Spring, and Lightman and other organizers. In 2030, late 2030, they have started make specification for the reactive stream for asynchronous data stream processing with the non-blocking and with back pressure. And this reactive system uh, were proposed to become a part of Java as well as Java standard in from Java 9. So when they are standardized, then Java come with a, in Java 9 they come up with a set of interface which reactive stream specification mention, so that your reactive system should be stream the data processing asynchronous, non-blocking with a back pressure feature. So, as per the stream reactive stream specification, they have a provide minimum only four interface. As per the reactive stream specification, they have provide this four uh, interface. For first interface is a publisher, subscriber, subscriptions, and processor. These are four interface only is the part of string reactive stream specification. Or any vendor, any company, any API implementation can provide these interface implementation, and if they want to implement reactive stream specification, they want to build the reactive systems. So in early days, these specifications are implemented or adopted by the following uh, uh, technology and companies. If you are looking about the stream, reactive stream uh, applications, the first Akka stream, MongoDB, Ratpack, Reactive Rabbit for your uh, Rabbit MQN, AQP, and similarly Spring and a pivotal known as a project reactor, which I am discussing. And the same reactive stream specification as majorly all are famous and old reactive stream system available in the RX Java, and also Snake, Vertex. These are the other implementer of the reactive stream specification. And apart from these major reactive stream implementation, there are other some database Cassandra, Elasticsearch, Apache Kafka, Play Framework, and other vendor also have provide the implementation of reactive stream specification. So from string 5 build the reactive stream computable reactor core. And on the reactor core basis, Spring, name as project reactors are implemented. And from string 5 onwards, you have a web flux and multiple string reactive stream implementation are found in Spring as well as. So till now we have discussed about the reactive systems and reactive stream specification. So we have discussed uh, reactive stream. Okay, reactive stream specification. And for this specification, if someone going to implement, then they follow some programming paradigm. So for reactive system, we known as a reactive programming as well as. So the reactive programming is a programming paradigm that is functional, event-based, non-blocking, asynchronous, centered around the data stream process. The reactive programming is a paradigm that mainly focus on functional programming concept with event-based and non-blocking asynchronous non-blocking. That is mainly center around the data stream processing. Data stream processing. So the term reactive means the term reactive comes from the fact that a system can react the change. If this is a system, if something change, something event happens, something that should be changed something. So that is the reflect of Java observer design patterns where you have to say some subject change, then what would the impact? So reactive means just react on the particular event, a particular change. So systems should be react to change. Just like if you click mouse or if you IO event, any kind of event happen after that, this do something. Okay, that do something on the to handle those changes, to react. So reactive programming generally whenever we know reactive programming is, this is the one kind of programming paradigm where whenever we are going to write code, that code be more in functional oriented concept, event based, non-blocking, asynchronous programming. Non-blocking and asynchronous, this is the key parameter. To implement non-blocking and asynchronous, we have to follow not object-oriented concept but functional approach, functional way. From Java 8 onward, due to the involvement of lambda expressions, we are able to write functional code in Java as well. The nowadays Java support both object oriented paradigm, how to write code in object oriented concept, as well as we can write code in a functional programming concept as well as. So the Java support, Java nowadays we can kind of provide this available lots of tools as per application, as per requirement, as per the application. Somewhere we can use your object oriented concepts, somewhere we can use functional concept, somewhere we can use both as per your requirement, as per the system design needed. So whenever we are going to implement reactive programming in Java, Java have these tools and capability available. We can write code in a Java language with a for the reactive system as well. So we can build a reactive system using Java. What reactive programming say? Reactive programming say we have to be functional, event based, non-blocking, and asynchronous. Asynchronous, that is just the multi-threading concept. Means your task is done by different threads. Non-blocking, if one thread do something, if you have let's invoke some IO operation or some DB call, this thread cannot wait to response of this thread. Instead, they are continue working its task. So in reactive programming, no, our threads, our processing task does not wait someone to complete. That is non-blocking. Asynchronous means maybe done by the multiple thread, yeah, from different thread pool. Okay, if we are writing a code in you are going to do reactive programming, the reactive programs have some feature. If we are a code in functional, event based, non-blocking, asynchronous, then your application automatically scale better and are more efficient when we are dealing with the lots of streaming of data. Whenever lots of data coming, you are processing here data, and someone might be consuming your data. In that case, if your program in the reactive programming manner, I follow these principle functional, event-based, non-blocking, and asynchronous way, your application automatically become a scalable. And reactive programming on your applications should be non-blocking. That means if your this is your application, someone send a particular request, this request is not waiting. They immediately take response. And if the particular resource they are demanded, if they are taking some time for those calculation for those resources, this request is not blocked. This should be unblocked. So that is the feature sorry are available if we are active applications are non-blocking. They are not using resources waiting for the process to finish. Also, a reactive application implements an event-based model where data is pushed to the consumer, and consumer of data like subscribe to the publisher which publish asynchronous stream of data. But the meaning here, in the reactive stream, uh, there are major two components. One is one system your publisher which publish the data, stream of data, and one system or multiple system are your subscriber which they are consuming process data. Here trying to say is the first thing we have to know, we have a data, okay, collections of data, list of data, array of data. You cannot, this is the and stream of data. A stream, what do you mean by stream? A stream means that the sequence of element, a sequence of data emitted on the time bearer. Particular times, you can say your temperature data, sensor data. Let's give temperature. Now at present the temperature is xy point. After second time temperature will be different. After third time temperature will be different. Or similarly you can stock price. Let's a particular stock a price a particular moment 100 rupees. Okay, after 1 year 2 second, the stock price would be 101. After some time, maybe point price would be 98. So on the time basis, they are omitted data, they are produced data. That is known as a stream of data, live stream of data. On the time basis, data is generated. So here the after the omitted might be this data can be the array, can be the list, can be the value, but the stream is just the sequence of element, that element omitted on the particular time. Okay. So here is the two major concept. One is your publisher, another is a subscriber. Publisher is publish the stream of data, consumer or subscriber just consuming those data. So let's discuss in this way. Let's see, producer is producing some data, producing some data, and this is the consumer consuming data, and let's key the producer produces data some speed, and this subscriber a consumer have a only capability at a time, they can consume a three element. Okay, what happened, they are producing four element or five element. So here would be a chance, here make some queue or buffer. They process three element and fourth is the waiting for the next processing. And after some time again they come with a four element. Now again five element. Then again pick up a three and do again processing. So after some time, maybe due to the slow capability of this subscribers, your buffer can be full. After that, what happen? Might be each buffer have some limitation. Your buffer is full. After that, whenever new stream of data come on the timely basis, data is generated and generated. Producer again produce data, publish the data. At that time, two cases are you can discard your old produced data, or we can increase memory and make again a queue, but there will be some limitation. You have a limit the queue size as well as. So here is the reactive system what they do. Here saying in the case of your subscriber is unable to process at the rate which the publisher is publishing data. Publisher is publishing rate is higher than the subscriber process rate. In that case, the concept come back pressure. What back pressure say, instead of now is there any capability that subscriber inform to the publisher I need only four element or three element or 10 element or two per second or five per second. Is there any mechanism through which we can control the as per my capability? As per my capability, this publisher can publish data to me. This mechanism, this channel where subscriber can intimate to the publisher this volume or this rate of data I can consume. This mechanism, this controlling volume is known as a back pressure. Now subscriber know his capability, his processing power. According to the processing capacity, they can control the volume of data that are published by your publisher. Okay? So this is the one of the key feature of stream, uh, reactive stream systems. So all this concept of publisher, subscriber, subscriptions, and the processing. So these are only four key parameters. Publisher is publishing the data, subscriber is subscribing, consuming the data. Third, subscriptions, where subscriber can request for the back pressure. I need this kind of rate. And finally, the processor. Processor is nothing new, just is the extension of subscriber and publisher. What do you mean by that? Sometime this is your publisher, publish data, this is your subscriber. Might be this subscriber become a publisher for another subscriber. So here for this publisher, this process come as a subscriber. For but this subscriber, this become as a processor. So this is a processor. Processor have a both capability. They can work as a subscriber. They can consume stream data from the publisher, and similarly they become a publisher to publish data for another subscriber. In those scenario, this is the processor. Processor is a both capability publisher as well as a subscriber. And subscriptions is the mechanism through which our subscriber can communicate to the publisher, say now I want to control the volume, how much request of data you publish to me. You notice that one publisher you can associate multiple subscriber can be subscribed. Each subscriber, as per his rate, their publisher can publish the data. So, in a reactive stream system, the communication between the two party or two systems, the two component come up with the three channel. What do you mean by one channel used for the data communication? Whenever you go to the subscriber and look on subscribe, there is on nest. Whenever you are invoking on nest, this is the data channel where data is publisher publish data to the subscriber. Second channel is the error channel. If any error exception occur, then handled by this channel. And third channel is a on complete channel. This channel means कि now subscriber want all the my processing completed. I want to complete the. I don't need more further. You can say data stream of data. Okay. So in this two way, these are the three communication channel between the publisher to subscriber happen. One channel for the data processing, another channel for the error handling, another channel for the on complete, on success or complete. So there is one catch here. What happen if the one data processing happen? If some error occur, some error happen, then this channel is stopped. Now move to their come next channel. Now in error channels, error communication happen. In error, to have options, we can stop. Now I am not able to process further, or might be case your system can handle error. If error handle, they can jump to again your data channel, and now again data channel can start sending a data. So in this way, jumping from data channel to error channel happen. Again from error channel to data channel also happen. So due to that, the system is maintain your fault tolerant system. So as per the your reactive manifesto, your system should be responsive, should be resilient, should be elastic, should be message driven. These are four. So here your system should be responsive in the case of data, in the case of failure, in the case of complete. Your system should be uh, elastic. That means there is no any blocking call. Any number of requests come, a system can serve. There is no any blocking call. All calls between the systems or components are non-blocking. So your system is capable to increase a high volume of data as well as, and all the communication happen also asynchronous manner. So these are the basics of your reactive stream specification, and the way reactive systems are designed, the benefits we are getting from reactive system. So, if we are going to write a code example, we have to take any one implementation and write a code to make our system, make our softwares or component as reactive systems. So for that, in my I'm going to take the use of your Spring frameworks, and Spring have a implemented stream reactive stream specification as a project reactor. Project reactor is a reactive library for building non-blocking application on a JVM. This building a non-blocking application for the JVM is based on your reactive stream specification. So all this project reactor, which provide the reactive library for building a non-blocking application, that is based on your reactive stream specification. What reactive stream specification say? We have published this for interface, publisher, subscriber, subscription, and process. So as per this set of implementation, set of interface, this interface can implemented by the Spring project reactor. So the project reactor offer two types of publisher. The publisher interface, they have implemented two kind of publisher. One publisher known as a mono, and second publisher known as a flux. So if now if we are talking about the Spring, so Spring reactive stream specification, they have provide two kind of publisher. One publisher is the mono, second is the your flux. If you are about talking what is the mono, what is the flux? Flux is a publisher that produce 0 to n values. Okay, that means your publisher can return publish 0 value or n value, any number of value. A second publisher known as a mono is your flux. If you are talking about mono as a publisher, they can they can produce value, any value, one value, or not any value, zero value, zero value or one value. There are two one mono have value or does not have value. If have value one value, that might be no any value. But in the case of flux, can have multiple value, publish multiple data, or nothing publish. So these are the two basic form of publisher that is provided by your Spring project reactor. Let's I'm going to write the basic example how we can use this publisher concept. Okay. So here I'm going to use just like a flux. So you can download the project reactor library from the your maybe Maven, and you can just inbuild your any plugin software. Here I'm going to let's flux. The flux is they provide a list of utility method. Flux provide the list of utility method through which you can publish data. In real time your stream of data is generated by the particular timely method. But for example, if you are going to run some example, for that we have flux as a library provides some utility method through which you can publish the set of data. So I am going to use one utility method like a range. Then you can provide from this number to this number. I want to publish the number to the subscriber, and just time from 1 to let's 10. So this is your one flux. This is your flux. Now this flux, uh, Until now, let's come right. So done. Let's just run my program is running or not. Now done. Okay. That means here whenever one is the very basic most important concept of flux is that whenever they as a flux uh, omit publish list sequence of event, sequence of data, data 1, data 2, data 3, data 4. For processing this data, might be you have to perform some operator. Maybe operator maybe some set of functions you have to do. Operator maybe filter. Operator maybe you are applying some mapping, transformation from one object to another object. These kind of processing capability also provide this flux object. You can perform map, you can perform filter, you can perform any kind of custom operate function as well. So these kind of functions in the flux known as an operator. So we can apply multiple operator on this flux. So here on the flux, you can apply, or you can say, I can apply flux dot filter. I want only even number. The element I am getting, I want to just print the element which are the even. Even. Okay. So you can perform as well as filter. Flux. So you have a, here you can get all the publish method, or you can rn you can do. And if you run again, they are not doing anything else. So these are the done. So this is your one operator. You can apply another operator, just like converting the double value of this all even number. You can say flux equal to flux dot. You can apply map, and all the elements which I am getting just multiply by 2. Okay. So these are another operator. So you can perform multiple operator on that. So now I want to collect those value. I want to print those value. So for that, one thing say uh, on flux they are apply multiple operator, operator 1, operator 2, operator 3, until you are not subscribe, until you are not subscribe to publisher. Publisher, that means our flux. If we are not if any subscriber is not subscribing to this publisher or flux, all the operator are not evaluated. That means that is the lazy evaluations. All the map operator, filter operator, range operator are lazy evaluation. Until you are not apply any subscriber, none of the operators are evaluated. So, how to apply some subscriber? Let's can apply subscriber on this flux dot subscribe, and I am subscribing it, and just I want to print those number. Now here I am now I apply subscribe one subscriber one. If you run it, notice that we are able to take all the even number between 1 to 10 and multiply by 2, means double of those even number, and we are getting it. So in this way, you can perform multiple until we are not doing any subscriber, until you are not subscribing this publisher. This is the publisher. If you subscribe this publisher and this is your subscriber just printing those messages. Before that, all the operator filter, map, range are not evaluated. When you apply the subscriber, attach any associated any subscriber, then these all operator are evaluated. Okay, and you can also apply multiple subscriber with one plus dot subscribe. Let's key I am a subscriber 2. You can say. So here I am going to let's key. I am changing it to yes out. Yes, subscribe 2. That's what are the evaluate. You can just subscriber multiple subscriber you can subscriber 3. Notice this is your subscriber 1, this is subscriber 2, this is subscriber 3. All subscribers are evaluated. So this is the one simple demonstration of a public subscriber interface of your reactive string programming. How we can say, if you notice that here our flux is your publisher, okay, and to subscribe any publisher we have to invoke the subscribe method, and here is our subscriber, what are the subscriber is doing. And here I am talking about the three channels. This is your data channel, and then your error channel, as well as your complete channel. The these three channels are also. Let's key I am subscribing subscriber. Let's key subscriber 4. If I have any error, you can pass somewhere exception. Any error, let's key any error come you can just pass out. Print error some happen, some happen. Yeah. Third option on complete. Okay. If you are getting some success value, just as I'm doing done success. 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 So these are the three channels as task done, yeah, completed. If any error happen, this channel can receive. If you are incomplete, this channel receive, and all the data processing, this channel receive. Let's see. This is. Oh, sorry. and now this is your success. If there is no any exception, this is not evaluated. When any error come, then this will be evaluated, and finally all the subscriber have completed the success complete message. They can use the third channel. So this is the very simple implementation provided by the Spring about the publisher and subscriber and subscriptions and process as well as. So all these four interface is very easily implemented and very easy and handy API provided by the Spring to the developer. Now developer you can easily just for making a publisher, making a subscribers, they can easily do. And if you notice that if you go to the code base of this Flux and you notice that the Flux is implemented by the core and core is implemented by your publisher. So this is your publisher, I have a subscribe method. Similarly, I have a subscriptions, unsubscribe. These are the three channels. I'm talking about these three channels. On nest for data, on error for your exception, and completion. So these are your subscribers, which are associated to the publisher on the unsubscribe method. So in this way, Spring provides the very concise, very simple and handy method through which we can write code in the reactive stream, and uh, all this your code is follow the feature of non-blocking asynchronous. These two three all are the non-blocking call, non-blocking call, non-blocking call, and whenever until the subscriber is not subscribed, all the existing operator is not evaluated. This is the lazy evaluation for the performance perspective. So hope it will be helpful for you. If you want to learn more, you can just go through the reactive stream specification, or if you go with the Spring project reactor documentation, you can go through the reactive uh, project reactor documentation part as well as. Uh, okay, the summary point is that the reactive systems uh, are those systems which are responsive, resilient, elastic, and message driven. Or to achieve these reactive systems, we have to follow the reactive programming. That reactive programming implemented through functional, event-based, non-blocking, or an asynchronous manner. Asynchronous and non-blocking is a key feature to achieve the reactive system. That all the capability are provided to developer in easy manner. We are using the project reactor of Spring, the in the form of Flux and Mono. We can implement non-blocking asynchronous application that help to achieve reactive systems. Okay, thank you. Thanks for watching this video.